afternoon, folks, and welcome to my talk on Circle's effective smart contract management solution. I guess I should get started by introducing myself. My name is Sarah, and I'm a software engineer at Circle, and I work on the stablecoin infrastructure team. I've been with Circle for almost a year now, and so far I've worked on a variety of crypto and blockchain-related projects. For a little bit more context, our team is about 40 people, and we handle most of the blockchain-related engineering here at Circle. In the last few years, we've launched USDC on 8 blockchains and contributed to issuing more than 50 billion USDC. We also worked on the recent Eurocoin launch, with more chains and coins to come in the future. Although we're 40 folks strong now, this certainly wasn't always the case. In the beginning, the blockchain work was done by a small but mighty team of 3. And this growth hasn't been easy, and we've run into some real struggles scaling up along the way, and one of those is actually what we're talking about today. In addition, as we expanded from USDC on Ethereum to the multi-chain world we live in today, with USDC on Avalanche and USDC on Polygon, among others, our initial manual process, if you can call it that, for managing smart contracts didn't hold up. And it didn't scale well for our larger group of engineers, and so we built a solution, and today we're sharing it with you. Many blockchains have a notion of smart contracts, and on these chains, smart contracts are foundational. At the very basic level, they're computer programs running on the blockchain which execute code when a condition is met, and among other things, they power USDC, and they allow for decentralized applications which do interesting things and increase the utility of the blockchain. So we've covered that smart contracts can do really cool and really important things. But they're also a bit scary to deploy. We'll contrast them with traditional application code. In your typical app, you do your best. You write some code, hopefully you write some tests, and then you deploy it, and you see what happens. And if there are any issues or if people find bugs, that's okay. You come back, you fix them, maybe you write some more tests, and then you deploy again. It's a pretty forgiving process, and there's lots of opportunities for iteration and to try and then try again. Smart contracts, though, are a whole different story. Once you've deployed your smart contract, it's out there forever. Whatever bugs exist, whatever issues people find, they're out there in the world. And there do exist some mitigation strategies, but overall, this process is a lot less forgiving. And so since smart contract deployment is so scary, you'd think that there would be really great tools to help give you confidence and makes things better. And unfortunately, this isn't the case. Instead, managing your smart contracts and getting them to the point of deployment can be very frustrating. Here's just a couple frustrations. The compilation is nitpicky. You need exactly the right compiler version and the right library versions, and your test library versions need to agree with your compiler versions, and it's just versions, 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 all the way down. And then, you might have several different smart contracts, or different versions of the same contract, and each of these might have subtly different requirements, just adding another layer of versions. And this can be so frustrating and so confusing that without even realizing it, you end up with smart contracts that aren't tested, or aren't sufficiently tested, or smart contracts that are compiled with slightly the wrong version, and that causes other issues. And so we've covered that the process is frustrating, and that deploying contracts is scary, and I think it's easy to see how this could all turn really bad really fast. Now, we'll talk about how Circle manages our smart contracts. Over the last several years, Circle has grown hugely. I mentioned before that we went from 3 to 40 blockchain engineers, and processes that worked once just couldn't keep working. Let me tell you a story of how we managed our contracts way back in the beginning. The contracts themselves, they lived in a random file somewhere. And when we needed to compile them, one engineer would go grab them, and they would copy and paste the Solidity code into the Solidity terminal, just running on their local dev machine. And then once the terminal generated the bytecode, the engineer would then copy and paste it again into a file and commit that file to our repos. It's pretty obvious that this doesn't work as the team grows. It's highly manual and takes up engineering time. There's lots of opportunities for errors when copying and pasting, and there's no way to audit what we've done and make sure it's correct. All in all, it's just not a great process. Another issue with this process is that it doesn't scale to multi-chain support. Here at Circle, we're fortunate in that we're able to share many of our contracts between EVM-compatible chains, such as Ethereum, Avalanche, and Polygon. Internally, this looks like us having a microservice for each of these chains designed to listen for and broadcast transactions onto them. The microservices each live in their own GitHub repo and each need a copy of the USDC contract to interact with so that they can send and receive, mint and burn, and manage deposit contracts. But for each new chain, and accordingly each new repo that we add, that's another place that the engineer would have to go to paste the bytecode. What a good use of engineering time. So I think this makes it pretty clear why we needed something better. In terms of solution requirements, we wanted to build a solution to help us scale. We needed some tooling or infrastructure to help with managing our smart contracts. But the tool needed to be highly configurable. We have several different smart contracts and different versions of these contracts, and each of these require specific compiler and library versions and have different testing requirements. The last thing we wanted was a centralized repository for our contracts. We talked a little bit before about how EVM-compatible chains share contracts, and our clients on those blockchains all need access to the same contracts in their source code. Ideally, we wanted to store the contracts in a centralized place and use established language-specific patterns for sharing them. For example, if you consider building Java services, this could look like turning the smart contracts into a Maven repository, which can then be imported by any service which requires it. As our initial solution, we moved all of our Solidity files to one common repo. In addition, we built some Docker images which contained the exact versions of the dependencies we were using. Then, we would start up a container based on the pre-built image and mount the contracts as a volume so it could access them. Inside the container, we executed scripts to use the installed dependencies to compile, test, or otherwise operate on our smart contracts and report back output. The output could be both on the terminal and in files created on the shared file system, including ABI and bin files and Java wrappers. The Java wrappers in particular could then be bundled by Maven and imported into other microservices that needed them. And the result? This did have a lot of really good benefits for the team. It totally removed the need for copying and pasting, saving time, and reducing opportunities for errors. It also allowed us to be consistent in testing our smart contracts, both with tools like Truffle and with static and dynamic analysis tools. And it made our multi-chain efforts a lot easier and smoother. And these are all really good things. But it still wasn't as configurable as we dreamed of. If we made new contracts that needed different compiler or test library versions, we had to build them new Docker images. And this is a one-time cost. It's not a huge deal. But it's certainly still a little bit annoying, and it kept us from always upgrading to the latest and greatest. And so we iterated. The way we extended our existing solution was getting rid of pre-building all those Docker images. Instead, we've created a configurable build system for smart contracts in the form of a command line interface. Our tool is known as the contract CLI. We can begin by installing the contract CLI from NPM as a global module so it can be accessed from the command line. When you initialize the CLI, it creates a config file and a series of build steps. In your config file, you can specify your contracts and the tests. And in addition, you create a list of arbitrary build steps, which will be executed in order. For each step, you can specify an installation script, which describes how to install whatever is required for the step, and an execution script, which describes how to actually execute the step. Each step also creates a corresponding directory into which you can place any relevant files, including the installation and execution scripts. You can also add other supporting files, such as a package.json, if your step is associated with an NPM module, or say a util script, if your step is more complex. Once you've configured your steps, you can run the execute command. This command binds your current directory as a volume to a Docker container it kicks off to allow the container to access your contracts, tests, and steps. Then, the Docker container runs. It executes your steps in order, first running the installation and then the execution scripts. All results of your scripts are reported on the command line, and any files created, such as ABI and bin files or contract wrappers, are shared back with the local machine file system. And that's it. Whatever existing infrastructure you have for your smart contracts should plug in easily and allow you to add further extensions as well. Let's now see how easy it is to work with the contract CLI by adding it to a very simple smart contract project. Oh, I'm seeing that the video can't be loaded. That's not a good sign. There we go. Yeah, it looks like it's project that we're going to add the contract CLI to. As you can see, it's named Contract Demo. Inside this project, we have a directory for contracts in which I have the counter solidity file. This is our very simple first smart contract. I also have a directory migrations, which has one migration which deploys our contract, and we're going to use this with Truffle to deploy and test our contract. Finally, I have a directory of unit tests, where I again have a single test for our smart contract, which we will again run with Truffle. Note that I'm using Truffle here as an example, but you could easily plug in a different contract testing library of your choice instead. Now that we've got an idea of how things are laid out, let's set up the contract CLI to run our tests for us. Admittedly, we could instead install Truffle locally and run Truffle test directly, but if we do that, we run into the possibility for version conflicts that can be hard to untangle. Using the contract CLI helps us to prevent that. We can type contract CLI init steps ganache steps truffle. As you can see, we are initializing the CLI and specifying two steps, ganache and truffle, which we will use to run our tests. You can init without specifying steps, which will use a default, or with any arbitrary list of steps that you like. So running init should have created our config file, config.json here, as you can see. Inside of this, you can see the two steps that we specified, as well as the contracts root and test root. In our case, the contracts root matches where we've got our contract living, but we need to update this test root to be unit tests instead. Running the init command also created our step directories, as you can see here, ganache and truffle. Inside of this, we have an install script, which runs yarn install, and that's based on this package.json. Here we picked a version of ganache, but you're welcome to specify a different one if you need something in particular. And then there's this execute script that runs ganache. Truffle is much the same, although it's actually slightly more configurable using this truffle config.js. Awesome. So now we're ready. We can use contract CLI, execute, which will start up a Docker container and run our steps in order. Here we go. Note that this first run can take a little while because it needs to download all of our dependencies, but subsequent runs run faster because the node modules are saved. There we go, ganache has installed and it's now starting up in the background. And now we're running truffle. There we go, we're compiling our contract. And our one test is passing, awesome. Next, let's say that we want to build Java wrappers so we can integrate with microservices. So we need to add in two more steps, solc.js, which will compile our contracts, and web3j, which will build our wrappers. Awesome, so we've added our new steps. Next, we have to take a look at our step configurations. We'll start with solc.js, and in particular, in the execute script, we specify where our contracts live, and we're looking for contracts as contracts solidity and contracts and then a subdirectory and then the solidity folders. Since we don't have any subdirectories, we can get rid of this. Let's also take a look at web3j. The execute script, we need to specify these targets and our package name. For our package name, it doesn't really matter because we're not moving forwards with the integration. But if you needed it to fit into your existing package structures, you could specify that however you need. In terms of targets, these refer to our contracts.
and they get generated as contracts, counter, sol, counter, though of course we could configure this better if we so chose. So next, let's re-execute the contract CLI, and you'll note that this time it runs much faster because the node modules are already downloaded. It's starting up Ganache in the background again. And then we're running truffle. Now we're downloading Sol.CJS. It's pretty lightweight, so it'll download quickly. Awesome, its installation is done, and now it's compiling our contract. We can see here that it's creating our build directory over here and created an ABI and a bin file for us, which is awesome. Now back over here, we're downloading Web3j. And then we've already run Web3j. And what that has done is it's created this target folder with our Java file in it as auto-generated code. And there you have it. That's the basics of using the contract CLI. I demonstrated today using Ganache, Truffle, Sol.C, and Web3j, since that's a toolchain we use a lot internally here at Circle. But you can easily plug in your own toolchain, however you prefer, and experience the benefits of using contract CLI to control your dependency versions yourself.
Did we pique your interest? We'd love to see people start using the contract CLI. If you're an end user, it's just as simple as the demo showed. You can install the contract CLI from NPM and then start using it right away to improve your smart contract processes. If you run into any issues or you have new features you'd like to add, you can let us know on GitHub. If you're a developer and you'd like to contribute to our project, again, join us on GitHub. There's lots of extensions possible, and we absolutely welcome new pull requests. In terms of next steps for the contract CLI, there's still quite a few features we'd like to add. First up is probably adding some more default steps, including for static and dynamic analysis tools, integrating with other frameworks such as Foundry or alternatives, and we would also be interested in adding steps to help with non-EVM contract development. We'd also like to add Rust and JavaScript integrations, since although we started with Java, we'd also like to support those. Other than that, we always welcome suggestions, or if you'd like to implement it yourself, you're more than welcome to put up a PR. That's about all we've got from me. If you'd like to connect with Circle, you can join us on Discord, Twitter, LinkedIn. You can play in our sandbox, and we're hiring. It's totally remote. It's a pretty fun place to work, so definitely would recommend. That's all from me. Thank you very much.